So what's happening in the process? In the feed, the gas oil is preheated to 300 degrees Celsius and is introduced into the reactor with steam. Now moving on to the riser part. In the riser, there are hot catalyst particles from a generator that are fluidized, and this is to increase the surface area and meet with the feed in the riser at temperatures 1000 degrees Fahrenheit. Cracking reactions on these fine particles that are fluidized are moving with the reactants and takes place in a very short space of time. So now, cyclones. The products go through a series of cyclones. These cyclones are used to separate small fluidized catalyst particles from the products. Moving on, the products will then go to the fractionator. The products are usually separated into gas, gasoline, light cycle oil, and heavy cycle oil, and finally the heaviest decant oil, which is the heaviest. So light cycle oil is used to make diesel fuel through hydrocracking and hydrogenation. Moving on, the reactor. The coke catalysts that have lost its reactivity are sent to the regenerators. The catalysts that are not regenerated are then sent to the reactor to close the catalyst cycle through the riser to meet the incoming feed. The air is injected through the bottom to burn off the coke. Temperatures could reach up to 1300 to 1400 degrees Fahrenheit. The catalysts now are much improved. That includes zeolites that could take in high temperatures and have a very controlled conductivity through pore size distribution. So this produces flue gases. Flue gases are sent to carbon monoxide reboilers that will convert to flue gases to carbon dioxide. So this carbon dioxide produces extra heat to power up the reactor. This makes the FCC process a very good heat integrated process because it recycles heat all throughout the reactions. Thank you very much, and that's it from me.
Hi everyone, my name is Abdurrahman Muazzin Ali, and I'll be covering on the old catalyst for this video. So to begin with, I would like to talk about fungicide. This is one of the old catalysts that I discovered. So let me give you guys some of the background before I start the video. So during the early 1760s, the mineral sublime was first discovered. This was known as the boiling stone during that time. So this led to the discovery of zeolite during the 1960s. So zeolite wine was first discovered and industrialized. You could say that this was the first industrialized catalyst during the time. So now I'll be telling you guys something about the synthesis of our fungicide. So fungicide is usually synthesized as other zeolites from alumina and other minerals. So there are a few uses to fungicide. So compared to the new catalyst, there are few lesser uses this time. So the first use you could say is used in fluid catalytic cracking. So this basically converts high boiling fractions to usual products, and it's also used in hydrocracking. So it is basically over there, it's used as platinum and palladium supports. So in the third uses, you could say it is used in selective absorption of carbon dioxide from other gas streams whichever going out. So I would like to end and pass it on to the next person. Bye bye.
Hello everyone, today we're going to talk about our new catalyst, which is ZSM5. This new catalyst is being synthesized on 1969 and it belongs to the pentyl family of the zeolites. The basic synthesis of this zeolite is that it is prepared at high pressure and high temperature in a teleform coated autoclave and be prepared using various of silicon oxides and aluminum containing compounds. The main use of this new zeolite is for the isomerization and alkylation of hydrocarbons. Example of isomerization is this catalyst can isomerize metaxylene to paraxylene, and for alkalization process it's used for increased octane numbers. That's all.
Hey guys, so my name is Manisha Narayanan and I'll be talking about the potential applications of zeolite Zirconium Mobile 5, also known in short as ZSM5, which is the new catalyst that we are discussing in our topic. So the first potential application of ZSM5 will be as a catalyst for diesel oil non-hydro dewaxing process, and this process basically decreases the freezing point of diesel fuel. So it can be used in mostly cold countries or during winter season to make sure that diesel does not freeze at very low temperatures. Other than that, we can use ZSM5 as a catalyst for deep catalytic cracking process, which is also known as DCC process. So this process requires a catalyst to convert heavy hydrocarbons to lighter olefins like ethylenes, propylenes, butylenes and many more. So ZSM5 is a catalyst in this process can be used to maximize the production of propylene. Next, we can also use ZSM5 in fluid catalytic cracking as a catalyst. So FCC is almost similar to DCC where it converts heavy hydrocarbons to lighter hydrocarbons. So ZSM5 in this process can be used to increase the yield of propylene and also improve the gasoline octane number. Other processes where ZSM5 can be used as a catalyst would be in xylene isomerization, conversion of methanol to gasoline and also aromatization. That's all from me and thank you very much.
Hello everyone, my name is Asta Lakshmi and I'm going to be talking about the new processes. They are divided into 4 separate processes. The first one being catalytic lube dewaxing process. This process removes waxy molecules from paraffins. The distillate dewaxing uses selective cracking of paraffins over the shaped selective medium for ZSM5 catalyst. The next process is aeroforming process. This process is designed to aromatize a large range of aliphatic hydrocarbons using a shaped selective zeolite doped with metal oxides. This process is based on multiple fixed bed isothermal tubular reactors. Also, the process is convenient for small scale production of aromatics. And the third process is naphtha to gas and gasoline process, NTTG. This process offers flexibility to operate in gas or gasoline mode by correct choice of catalyst formulations. This process also produces LPG, which is in high demand in Southeast Asian countries such as Japan and India. And for the last process is the methanol to gasoline process, MTG. In this process, olefins are formed as intermediate and the secondary conversion of these intermediates by various reaction steps. So zeolites were replaced with ZSM5 catalyst. Since this catalyst has medium pore channels, it is the most suitable for the purpose, which can accommodate for aromatic but restrict the formation of higher aromatics and coke. That's all from me. Thank you.